Hi everyone, my name is Rangit Pan and I'm presenting our work with full A, Nachiappan Nagappan, Sumit Golwani, Shubhendu Lahiri, and Mike Kaufman. This work has been done during my internship at Microsoft Research. Today I'm going to tell you about our work on resolving merge conflict using program synthesis. Before we dig into our work, we want to briefly discuss about the merge conflict in general. Merge conflict can broadly happen in one of the two ways. First, user 1 commits the changes in branch A and user 2 takes the changes and updates that. At the same time, user 1 makes some changes and pushes that to branch A. When user 2 tries to push the changes, the conflict occurs. In the second scenario, user 2 creates a for branch and makes the changes in the branch without the knowledge of the kind of changes happening in the main branch. When user 1 or 2 tries to pull the changes of the other branches, conflict might occur. Now the question here is how to resolve this conflict. Are there any patterns in a resolution? If there are patterns, can we learn the pattern to propose an auto-fixing technique? Here, the prior work by Ghito et al. Have greatly motivated us. The prior work observed patterns are commonplace in conflict resolution for a large project when viewed over the history of a project. They also postulate that learning common resolution patterns in a project can be a useful aid for developers in resolving future conflicts. Based on that observation, we tried to answer whether we can learn repetitive patterns from a project and apply them to the same. We have carried this work on Microsoft Edge to learn the conflict resolution patterns using program synthesis. Here we show some example of what patterns might look like. One such examples, the top one, where the header cursor type module shared or cursor type module blink appeared both in the fork and the main branches, and the developer excluded the one in the main branch. Similarly, the bottom examples show another pattern, where the developer removes base login.h from the fork branch because Microsoft Edge uses a different login system. This example demonstrates the existence of common resolution strategies in the history of a project and the value of learning such frequent patterns to automate future conflicts. To the end, our contributions are the following. We performed an empirical analysis of merge conflicts seen in Microsoft Edge. A domain-specific language has been proposed to address the include and macro-related patterns established by the empirical evaluation. A top-down program synthesizer has been used to learn the program in this DSL to resolve the conflicts using input-output examples. Finally, the dataset and codes are available. In the data collection step, first we identify the merge commits by filtering the commits with two parents, one from the main branch and one from the fork branch. Next, we replay the merge commits for obtaining the conflicting files for each merge commits. Along with the conflicting file, we store the resolved version of each conflicting file. We have two datasets. One has been used for the empirical evaluation as well as for the training of the tool. And we do have another dataset that is 4 weeks of data that our training approach has been tested on. This table summarizes the dataset. In Microsoft Edge, on average, every week there are 37 merges, and out of that, 33 are conflicting merges with 270 conflicting files and 852 conflicting chunks. In this work, we have answered the following research questions to understand the common file types to have conflict, the size of the conflict, what are the location in the code where the conflict mostly happen, and what are the resolution patterns. In this presentation, we will be focusing on the size and the pattern-related research questions. For other research questions, please see our paper. First, how large are the conflicts? We created 12 groups starting from 1 to 2 lines to more than 50 lines and compute the same for each type of the file. We refer to the conflicting size as the number of lines reported by the conflict markers. And we found that majority of the conflicts are of 1 to 2 lines, and also 28% of the conflicts in C++ are of 1 to 2 lines for both main and fork branch. The second, what are the conflict resolution patterns in Microsoft Edge? Here, we empirically evaluate every 1 to 2 lines of changes that both main and fork branch and identify the pattern based on the type of operation that the developer did to resolve the merge conflict. In this context, any resolution that removes the conflict markers is treated as a conflict resolution. And out of these 9 patterns, we will discuss 3 patterns, and for details about the rest of the pattern, please refer to our paper. A vast majority of the resolution strategies are based on keeping both the changes that result in the conflict. For example, in case of changes in the input statement, the developer can often take both changes. We found that there are some repetitive patterns where developer remove a specific header, for example, the base login.h. This is a project-specific pattern which is due to the fact that fork is using login function differently than the main. Often, main or fork branch moves the file into a different location, update the same in the code. To resolve such conflict, developers tend to remove the duplicate include statements. The empirical study has identified several patterns for resolving merge conflicts. We use these high-level patterns to guide the DSL to resolve conflicts. We now discuss the use of program synthesis to learn programs expressing these patterns. For example, we apply program synthesis to learn the observed pattern. We use the PROS framework as an inductive synthesis framework. This is our DSL. Our work is mainly focused on the 1 to 2 liners of changes in include and macro section in the C++ file. The input for the training is the conflict and the resolution, and output is the learned program. And for the resolution, the input is the conflict itself, and the output is a program that resolves the conflict. Now, recall the motivated example. The desired behavior is to remove the header base login.h from the fork branch changes, then concatenate the changes in both branches. Additionally, we need a guard to only execute the resolution above when the fork branch contains base login.h. Otherwise, the resolution would blindly apply to other applicable cases. Here is a program that expresses the pattern. In this program, apply checks if the fork branch of the input X contains the header base login.h. Then returns the result text as the concatenation of the main and the fork branch having the header base login.h removed. Similarly, this is another pattern where the duplicate header has been removed. Our study highlights that the learning project-specific pattern is beneficial, and we are able to address 11.4%, which is 41% of 1 to 2 lines changes seen in the C++ file. And we can resolve the conflicts with 93.2% accuracy, and also for the unseen data, the accuracy is 91.17%. The prior works are closely related. Prior works are the Gato et al., who performed a large-scale study of merge conflict over Java project, the J-time work that proposed the structured and semi-structured merge tool. The motivation behind this work was to inform how program synthesis can be applied for assisting the merge conflict resolution that can be beneficial for 2 reasons: flexibility to accommodate new patterns, adding explainability to the resulting suggestion. To the end, we have seen how we have collected data set. We answered 4 research questions and proposed a domain-specific language and used program synthesis to resolve the merge conflict, and data and codes are available. Okay. Thank you.
Okay, welcome again, everybody, to this 3rd paper of the session Handling Ecosystems of Fork Projects. And now you just watched the video of the paper, Can Program Synthesis Be Used to Learn Merge Conflict Resolutions and Empirical Analysis? And I'm glad to present one of the authors of this paper. We have here Ranjit Pan. So welcome. Let's wait for some questions from the audience. If they don't come, I have some.
Sure.
So I would like to congratulate you for the work done. I liked your proposal. And I would like to know, I mean, although it seems promising, you did it in the context of Microsoft and projects that are related to Microsoft. So I would like to know what kind of characteristics should other forked projects have in order that this approach, the approach that you follow, can be considered feasible also for them. I mean, let's say other forked projects in other companies or even open source projects that are completely free.
Okay, so when we started the project, one of the things we are actually looking for is that there's a previous paper in TSC 18 that had one line that was kind of motivating thing for us, that anything that we learn from the project can be applied in a project. That was the motivating part for the whole work.
Yeah.
So based on that assumption, we started this work, and anything that can be extended this work to other ecosystem or other company projects. The thing is that there is something repetitive things should be applicable.
Yeah.
Obviously, in totally open source projects like in GitHub, it may not be possible to extend at that point of time because there are very much noise present. If at least for company project, it can be extended. And definitely this DSL will not be directly extended. It needs some update, and even either updating the DSL is needed, or it can be trained. The actual resolution may be different from company to company.
Yeah.
And our DSL needs to be trained with some examples from that, and then it can produce the learn program that can be used to resolve the merge conflict as well.
Yeah, and also I was thinking that related to DSL. So have you thought if this DSL that you are or you have now from this project can be reused in another project? I saw that you have this as a future work, but I would like to know what is your preliminary feeling about it. I mean, there are several things that you already have in this DSL that can be easily reused in other projects?
So this whole study is actually divided in two parts. One is the empirical part, and the second part is the proposing the tool by having the DSL and applying the program synthesis. So we learn the patterns by empirical analysis, and then we apply it into a DSL. If the similar patterns is present in other projects or company, definitely the DSL can be applied. But however, there may not be. So those things our DSL cannot handle. So the one of the proposed work is that I know people are working on also, and that is the first step, that empirical analysis part, and that automated that part. So learn the patterns as well and make the DSL based on that. So this can be done fully automated, but the first part needs to be automated first, the empirical analysis part.
Okay, I think this is quite positive because the first phase of the study, as you say, the empirical study and classify the nature of merges and so on, it's hard. I mean, it's not so easy. And also designing the solution patterns, I mean, it's not so easy. And so I think that, as you say, that if you can automatize more or less this process, you can help, I mean, the other companies, other projects that can try to uptake or use your approach, right?
Another thing is about this approach is that the end product of this approach is a program. The program is kind of transforms, takes the merges and the conflicts and give a resolution. When you have the program and that program is running, I mean, given to this big company like Microsoft, and they need to understand why this resolution is been given. And any other learning programs, ML related, they give a decision, but very often they don't know why the decision is being taken. And it's not a resolution we are giving a suggestion to the developer. We should take the suggestion or may not, I mean, just remove the suggestion as well, but it's a developer choice till now.
Yeah, it's just a support for the decisions that they will take.
Support for the decision. And
yeah, but anyway, it's important because you can support people that are novices, let's say, and they can see more or less the pattern that other expert people.
We do have, we find that the developer who are the very mature, like 5 years, 10 years doing this, working on the Microsoft Edge and this Chromium. Chromium was actually been forked from last year, Jan. And then they are very much familiar with this kind of conflicts, but the problem happens when the new developer comes and they are not familiar with the what's done. So this is the way is kind of documenting what the senior developer had done and giving it to the new developers.
Yeah, this is important. And we have another question here from Sridhar. It's interesting work. Did you find patterns beyond structural merge conflicts? And do you think this approach could be thought for merge conflicts in projects with cross-programming languages?
Hi, sir. Thank you for the question. Yes, we did find patterns other than the structure merge conflict, but our tool is based on the structural merge conflict because of that. One of the reason is that it was done in my internship, where it was a 3-month period, and it was too small for completing this work also. And yes, and this work can be applied to the other languages, programming language as well. So we did for the C++ because both the Microsoft Edge and as well as the Google Chromium, the best programming language is C++. And also doing other language is easier because they have a good AST and building tools, but C++ very few is, even there is not much there in the for AST building. And for at least Java, there are a bunch of tools available that gives the good resolution.
Okay, so you mean that it's probably worth for those that don't have
yes,
too many support, because they are where the
yes, and C++ is kind of has a bigger chunk of portion in the industry related code.
Okay, thank you. I don't know if the audience have more questions. Well, here we have another one. They say very interesting. It's Hideki Hata. It's a previous author of this session. It's regarding the file type analysis. Are there few merge conflicts issues in the build files?
Yes, so there are merge conflicts in the build file, but the way they have been handled is that every time they take the code, Microsoft Edge people take the code from the Google Chromium, they rebuild it. So even if there is merge conflict, that will be gone by just cleaning it and rebuilding it. That's why we are not concerned about the build file related problems.
Oh. Thank you. We have some compliments and here. And another question from Paul Robinson. I'm very excited by this work. My company uses LLVM, and we see many merge conflicts. I would love to add an automated resolution step to our continuous merge process. Perhaps you answered this before, but have you tried applying this to other projects?
Not till now, but there are work happening at the company. So I'm not an intern anymore, so there are other people working on that, definitely.
Good. And probably, Paul, his company have data that they can try to make a feasible.
You can reach out to me or any of the other authors. There's email address is there, so they will be love to chat with you also.
Good. So we are almost running out of time. So thank you very much to you and all the authors that have participated in this session and the audience, of course. We will be moved to a discussion room to continue the